Corporate finance practice problem within OneNote. Future value with uneven investments. Don't leave profits solely to chance. Instead, use corporate finance. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if would like to, we're going to be in this tab on the left-hand side. We're in the practice problems and then down in the 922 future value uneven investments. Here we are in OneNote. If you have access to OneNote and would like to follow along, you're not required to, but if you would like to, we're going to be in this section and this icon up top. We're in the practice problems. We're down here in 922 future value uneven investments. Also note, if you're using OneNote, you might want to check out the immersive reader. We will have some complementary presentations down here with the text files that could complement having the same basic number and title as the practice problems. Those will basically be transcripts that can then be translated using this tool to other languages, and you can actually play the audio in English in other languages as a complement to this tab as well. Closing this back up, we're going to have our information up top. We will then do our calculation in the blue area down below. We'll do it in a few different ways, one with a mathematical formula. We'll also take a look at a running balance type of calculation, possibly an Excel kind of format, how you might put it into an Excel type of calculation, and then use of the tables. Now we're looking at a future value type calculation here, and normally when we break down these present value and future value, or let's just think about future value at this point, we then have the future value of one or the future value of an annuity. But we can think about situations where things become uneven or things are not uniform in terms of a fixed number of payments or fixed interest rates. And then we'd have to break down our calculation or our projection into more detailed projections. This becomes burdensome to do if you don't have something like Excel, but with something like Excel, it becomes a little bit easier to do. We just have to visualize how we can then use our tools here, our future value tools, to break down more complex types of scenarios. So for example, we have the original investment in this scenario being $14,000 for 10 years, and then the percent is going to be 11% for those 10 years. Then we're imagining we take the proceeds from that after the 10-year investment, put them back in for another 12 years at 15%. So we have the future value of one. We don't have an annuity situation. We're not putting more money in each time, but we have a difference in the percentages that will come into play. Therefore, it's a bit more complex than just a future value of one, and we'll have to do basically two calculations in order to do it. So first, let's do it with a mathematical formula. Formula being future value equals the present value times 1 plus r to the n. The present value then being the 14,000 for the first lineup that we'll have to do first. 1 plus r being the 11% to the n, that being the periods, in this case 10 years. We'll do it in kind of a table format. We're going to break this formula out into, in essence, a table format. So we're going to put the PV times this whole thing in the outer column and then calculate this detailed information in the inner column. So there's the present value of the 14,000. Then we're going to take the 1 plus r to the n. So we have the 1 plus r is 11%. And if I add those up, we get 111%. Be careful with the decimals because, again, if you did this in a calculator, you would, of course, be doing something like 1 plus 0.11. Converting this to a percent would be 1.11. And if I convert that to a percent, it would be 111%. So then we're going to take that and we're going to take it to the power of 10. So you're going to need some kind of calculator that has the ability to go to the power of the 10. If you do that in the computer calculator here, Windows calculator, let's go ahead and pick this up. We have a scientific calculator. So we can then say this is going to be 1.11, and then this is to the power of 10. And that's going to give us about, if I make it a percent again, it's the 284 about. So note this is rounded right here. This is the actual number up top. If we take that then and we multiply it times the 1414000, then we get about this 39,751.89. So take into consider rounding as we go with those calculations. I probably won't do the full calculation in the future, but make sure you got the calculator that you can do that to the power of 10 with, and be careful with the percentage and decimal conversion. So now we're going to take that amount and then do our second component. So now we're at the end of that time period. We've got another present value of 1 in essence for another 12 years. So for 12 years from that point in time is what we're thinking now. So we're going to do our same kind of calculation, same formula here, but starting at this point for the second component. So now we're going to pick up that 39,752. This is rounded, noted. And then we're going to say that we have then the 1 plus r to the n. So there's the 1 plus r is now 15 for the second time period. So that's going to be 115% or 1.15. And then we're going to take that to the power of 12. To the power of 12, the number of periods. That's this n up top. And if we take that to the power of 12, we get about 535. Note, again, take into consideration rounding here. And then if we multiply that out, the 39,752 times that 535, we get the 212,682.57. So that's one way we can do it with a formula. We can also, of course, do it with a running balance table. Maybe not, of course, do it with a running balance table, but you could do it with a running balance table as well. And this could be tedious to do by hand without an Excel worksheet, but quite easy to do with an Excel worksheet. I highly recommend taking a look at the Excel worksheet. To do that, we do have the practice problem for it, and it gives you a lot more detail on the calculation. So we could say, for example, this first half here, we're going to say in period 0, I'm just going to name it period 0 to 10. At period 0, we started at the 14,000. And then we took that 14, and let's plug that 14 here, 14,000 times 0.11. Now we got the 1,540. Adding that to the original 14,000, we now have 15,540. And then, of course, we could take that amount and we could say, let's multiply that times our rate, 0.11. That's going to give us our 1709 about. It's rounded, plus what we had before, which is the 15540. And that's going to give us our 17,249. And then if we go to the next one, we could see how it's growing here. We could say, let's times this times 0.11, and that's going to be the 1897 about. Adding that then to the 17249.4, we get the 1914686 or about. So let's go ahead, and if we do that all the way down, which again is tedious to do like we're doing it by hand, but with Excel you can use an autofill feature, which I highly recommend getting good at, because this type of running balance calculation is very useful and very easy, and something that is worth understanding. So then if we get to this ending balance, the 39,751.89, we could then go to the next period out, which is our second calculation. Just do the table again with our new rates. Now we're at period 0, which is really period 11 after this time period, and then go out 12 times up again. This is period 0, period 10, and then followed by the next time period. So we're going to start here, do the same thing. And we'll just take the 39,751.89 times the 0.15 this time instead of the 0.11. And that would give us, in this case, the 5963 plus the 39,751.89. That gives us the 45,714.68, and so on and so forth. And we can get that running balance that would take us back down to this 212,682.57. You can also see how this kind of scenario could lead us or make it easier for us to do more complex types of calculations, because if I have this situation where I think the rate is going to change constantly, then of course I can do this running balance calculation and change the rates as necessary within it. Not too difficult to do with Excel. So if we go back down again, let's try to do it again. Now this is going to be with an Excel formula. We'll just kind of break down the Excel formula. Note that you can pick up the Excel formula in the Excel practice problem. This would probably be the most common way of someone doing this in practice type of problem using Excel or a financial calculator in a similar way. So once again, we would have a formula down here. We're going to take the future value of one type of calculation and just plug this into our formula and just have it magically appear. So it would be the negative future value, which will flip the sign of brackets, and then we got the rate. The rate would, of course, for the first one be 11%. This cell would represent the number of periods, which would be the 10 for the first one. Notice that we skipped over this item here because it's not an annuity, and if it were an annuity, meaning multiple payments, that would be here. We're just going to skip that 2 commas and go to the present value, and that'll give us, once again, our calculation for that first component, basically magically. And then we can go back down and do the second component where we do the same thing. The rate now is now the 15%. The number of periods is now going to be 12 and 2 commas because, once again, it is not an annuity. And then we pick up the present value, which is now this number, the 39,751. 39,751. And that once again will give us our magical end result number. This would most likely be the easiest way to calculate this, although the least transparent. And just note how flexible these formulas are that we're using, the present value and future value formulas of both annuities and present value of one. Very flexible and useful formulas to be put into place if we can basically understand and visualize how and when to put them into place. We can then, of course, do this with the tables down below. We do a similar type of situation. We would take the first amount at the 14,000 and look at the table, and we would say we want 10 years, 11, so 11%. And 10, 11%, and 10 would be that 2.8394. There's the 2.8394, so the 14,000 times the 2.8394 is about 39,751.60. Might be slightly different due to rounding, due to this only going out 4 digits. Be careful of rounding. Then we could take that 39,752 about, now that's about our starting point, go to the table, and now we're looking at the 15% and 12 periods. So here's going to be the 15%, and the 12 periods would then be down here at the 5.3503. There's the 5.3503, so the 39,752 times the 5.3503 gives us, once again, that 212,682.99. Could be slightly different due to the rounding that is taking place in these two calculations for these two percentages, taking them out only to 4 digits.